Welcome to the King Extra class. In today's video, we're looking at a quick introduction to permutation and combination. Now, if you check my video very carefully, you'll notice that I've done some videos on permutation, and then I start with factorial. So do want to check those videos before you commence into this. Now, I'll just be doing a quick introduction on permutation and combination, and I'll move on with permutation from where I stopped, and then from there, when I finish permutation, I'll now enter combination. Now quickly, we say permutation of n distinct objects taking R at a time is an arrangement of R out of n objects with attention given to the order of arrangement. Okay, so as always, let me explain what this relatively means. We have a permutation of what? N distinct objects taking R at a time. Now n represents the total number of objects we have on ground. Our R represents the order of arrangement. It represents the way the number is arranged. And I've said what is the arrangement of R out of n objects with attention given to the order of arrangement. That is, if I say I'm giving 1, 2, 3. Now the difference between these three, each of these terms is 1. So, and since the said permutation takes note of the order of arrangement, it means if you are saying 1, 2, 3, it must be 1, 2, 3. If you are saying 2, 3, 1, it must be 2, 3, 1. If you are saying 4, 5, 6, 6, it must be what? 4, 5, 6. It means it gives attention to the order of arrangement. So we have distinct objects, we have attention given. And distinct objects, we have arrangements, of R. Then we have what? Attention given to the what? To the order of arrangement. Now, formula of permutation now becomes what? N permutation R equals n factorial over what? N minus R factorial. That is the total number of elements present, over the total number minus each of this order of arrangement, the factorial of each of them. The combination of n different objects taking R at a time is a selection of R out of n objects with no attention given to the order of arrangement. Now, in this case, we have n different objects. We have selection of R, that's the order of arrangement, and then with no attention given. That is, in this case, so I have 1, 2, 3. 1, 2, 3 is the same thing as 2, 1, 3. Is the same thing as 2, 3, 1. So since this is the same, it means I can pick any of them to represent the combination of these three elements. Now, unlike permutation, 1, 2, 3 is 1, 2, 3. If we are talking about 2, 3, 1, 2, 3, 1 is 2, 3, 1. They are on their own. So it's just like permutation is independent, and then combination relatively is dependent. So something like that. Now let's see this example. Consider the alphabet ABC from which 2 letters at a time are to be chosen. Now, how would the permutation look like, and how would the combination look like? First, we are selecting 2 letters from this alphabet. So for the permutation, it becomes n permutation R. My n is 3. Why? Because we have the total number of elements in what? 3, ABC. Then we are picking 2. Now this now becomes what? 3 factorial for my formula. Okay, for my formula of combination, it becomes n factorial over n minus R factorial, R factorial. In this case, you can arrange it like this or like this. Okay, so that's that. Now, so this now becomes what? 3 factorial over what? 3 minus 2 factorial. Now, on expanding, this becomes 3 factorial over 3 minus 2 is 1 factorial. I told us that 1 factorial is the same thing as 0 factorial, which is 1. So that's 3 factorial over 1, which is 3 factorial. And 3 factorial is what? 3 times 2 times 1, which is what? 6. It means my permutation of this 3 alphabets, selecting it 2 at a time, I'll get 6 arrangements, which I'm going to be showing us very soon. Now for my combination, the formula is also what? Now the formula here is n combination R, which is n factorial over n minus R factorial, R factorial. In which case this becomes what? 3 factorial over what? 3 minus 2 factorial, still 2 factorial. Now R represents 2, n represents what? 3. So 3 minus 2, 2. Okay, so this now becomes what? 3 factorial over what? 3 minus 2 there is 1 factorial, 2 factorial. Remember 1 factorial is 1. So I'm left with 3 factorial over 2 factorial. Now 2 factorial is 2 times 1, or I can say 3 times 2 factorial over 2 factorial. Where these cancel themselves, my answer is what? My answer is 3. It means for the combination of these 3 alphabets, selecting 2 at a time, I will have only 3 words arrangement. Now, how do I arrange this? In 6 ways. Now, I'm giving ABC, and 2 is selected at a time. So it means I can have AB, I can have AC, okay, I can have AB, I can have AC. That should be all for A. Going to B, I have BC. Okay, I have AB, AC, and BC. Now, let's take the inverse. I have BA, I have CA, and I have what? CB. Now, remember permutation, there's no attention given. There's attention given to the arrangement. So that's why AB is AB, BA is what? BA. We cannot say that commutative law applies here. Now, but for combination, it's going to be what? AB, AC, and what? BC. So since in this case AB is equals to BA, AC is equals to CA, and BC is equals to what? CB for combination, that's why we have only 3 arrangements, and for permutation we have what? 6 arrangements. That's that about that. The next class I'll be solving some other questions under permutation, then maybe one other combination before I now focus more on permutation.